In this series of videos I'm attempting to repair and restore this HP9845B vintage computer. In the previous video in this series I was working on the tape drives. I modified them, this is one of them, and I changed the capstan, modified it so that it would accept the DC2000 tapes. Come back to that in a few minutes. And refitted the drives to the machine, refitted the two tacho boards. There are two drives in this machine, each one has its own controller board. But when I came to test them, not surprisingly, they didn't work. Neither tape drive worked and neither of the two tacho boards worked. And these boards, like the main CPU boards on this machine, have these custom hybrid modules. So the question is where to start on a machine like this, fairly complex tape drive system. And I did start to video the repairs, but because of the way the boards are laid out on the machine, the videos didn't really come out very well. You couldn't see what was going on, and I only got as far as repairing the tape drive, but decided at that point to make up this adapter so that I could lay this all out on the bench, and hopefully you can then see what's going on. The other issue I had was I didn't have any viable tapes. I do have a few tapes that I received with the machine, but as with all these old DC100 tapes, none of them seem to be usable. In my opinion, the DC100 tapes are the HP equivalent of reefer caps. And in as much as it's very unlikely you'll ever find an original one that will work. It might work once if you're lucky, but beyond that they will almost certainly destroy themselves. The main issue is the magnetic material on the tape itself tends to come off and clogs up the tape, causes all sorts of problems, and also the drive belts disintegrate. These two tapes, you can possibly see I've replaced the drive belts in them, so I can now at least use these. In the process of putting together a test jig so that hopefully I can read tapes at fairly slow speed. One of the problems with these drives with old tapes is it does run them at very high speed. And that was the first issue I was having. When I put even a new tape with a new belt in, put it into the machine and tried to rewind the tape, it just kept throwing off the belt. It didn't matter how many times I took it apart, how carefully I cleaned the spindles, it did the same thing. So this is when I started to video, but I won't repeat the process. I tend to video as I proceed. But what I was doing was putting a scope probe onto the tacho output. So there's a tacho disc on the motor, and essentially it's giving out, or should give out, around 980 pulses for every inch of tape that goes past the tape head. It's quite a high resolution system it uses, and when the system is reading or writing the tape, it runs the tape at about 20 inches per second, so you should get a little under 20 kilohertz coming from the tacho. And that's what I was getting. It was running the tape at slow speed fine. But when it fast forwards or rewinds the tape, it runs it up at about 90 inches per second. But when I put the scope on, instead of getting the expected sort of 88 kilohertz, I was getting about 104 kilohertz, something like that. But more importantly, when I put the scope probe onto the data output from the read-write head, you can kind of see the pulses and measure the speed that way. When I used an original tape that had data that presumably had been written to it at the correct speed, I was getting the equivalent of about 135 inches per second. So something was obviously amiss. Also, the output from the tacho was very uneven. I wasn't getting what you would normally see as a regular output. It normally ramps up to a given speed, accelerates up fairly quickly, but then it's fairly consistent. But I was getting very variable pulses out of the tacho. So I think what was happening was it was not seeing every indicator or every mark on the the encoder disk. So it works in a fairly simple system. There's a small bulb shines through the disk and then an optical sensor. But if it can't see all the marks on the disk because maybe the disk is damaged, then obviously it runs up faster, and there's a D2A controller that drives these two transistors. So it's not a differential drive as such, it's each of the two transistors drives the motor. One pin on the motor, one connection on the motor is connected to ground, and then the other one is connected through one of these devices to either the plus 17 or minus 17 volt rail, depending on which way the tacho wants to drive the motor. And it's an analog system, so it can drive the motor at different speeds, and it uses a feedback system, so it monitors the speed the tacho is indicating the motor's spinning, and it adjusts the power to the motor accordingly through a D2A controller system. So quite a nice system. It is fairly granular. It's only a 5-bit D2A, which means it can't achieve an exact speed match, and the speed's not really set by the diameter of the drive capstan. That capstan does need to be fairly accurate, because that dictates the pressure it's putting onto the drive wheel inside the tape. But it doesn't really set the speed. The speed is set by the feedback system, but it is, as I say, fairly granular, so you will find it will be slightly too high or slightly too low. But this was way out. Now what it turned out to be, or rather the fix, I think it was just the encoder disk has degraded. But to fix it, what I did was I rotated the small bulb slightly, and the bulb, of course, it's an incandescent bulb, it's got a filament in it, and the filament will be it's orientated in a particular way within the bulb, and so if you rotate the bulb, then the filament will of course rotate with it, and that will change the characteristic of the light shining through the encoder disk. So I rotated it one way about 30 degrees, and it started working. So it now works reliably, it runs at the right speeds, and it stopped just destroying tapes as soon as I put them in there. As I said, I have got a new old stock tape. I did have to replace the belt in this. The original belt, even though the tape had never been used, the original belt just disintegrated as soon as I tried to use this. But I generally will be using DC2000 tapes. These tapes do need to be modified to work in the 9845. If you're using other HP machines, quite often they will work unmodified. You do need to modify the tape drive and extend the capstan so it will engage with the taller tape. But in the 9845, if you try an unmodified DC2000 tape, when you try to initialize the tape, which is equivalent of what we call formatting these days, if you try to do that with an unmodified tape, most likely you will get an error 81, which is kind of a generalized error for the tape system. It means that it thinks there's something wrong with the tape drive system. And I'll come back to exactly what the issue with the tapes are in a separate video, but you can modify them quite easily, and that's what I've been doing most of the work with. In fact, you can see the dark line that's starting to form on the capstan where I've been driving the tape. This has so far had probably 5 or 6 hours use. But what I want to do now, the tape drive does now seem to be working. I did have no output from the read-write head either, but that was just a broken lead going from the read-write head. The other thing I've done with this drive, I don't know if you can see them, I fitted a couple of turn pin sockets, and that's so I can fit a resistor across the this is the resistor that sets the write current for the read-write head, so I can just plug this resistor across the existing resistor to adjust the current, and that's to account for the different coercivity of the DC2000 tape compared to the original DC100. It's not fitted at the moment because in this testing we'll be using a DC100 tape, but if you do want to modify it, the original resistor is 200 ohms, and assuming that was the idealized value for the DC100, for for the DC2000 it needs to be around 166 ohms. So if you put a 1k resistor across the 200 ohm, you get 166.7, which is easily close enough. This also has fairly aggressive pre-compensation, so you do need to make sure that you're not writing too much current to the read-write head, otherwise the pre-compensation will kind of overdo it and you'll end up with incorrect pulse lengths. This system works by encoding the ones and zeros as different pulse lengths, and it's dynamic in as much as there's a ratio between those two. It doesn't really matter what they are within certain limits. It looks at the difference between short pulses and long pulses, and it uses the difference with a certain threshold value to determine if it's a long pulse or a short pulse, irrespective of the actual pulse length. Now, to do that, it's got a fairly simple electronic system. Just grab the schematic. So this is the block diagram for the tape drive system. So we've got the tape drive itself on the right, and then we have the main tacho board here. Now the bottom section is for the servo drive, the motor drive, and I'm fairly certain that's working, or at least it seems to be working reasonably well. It is now giving us the correct tape speeds. It runs at slightly under 20 inches per second at the slow speed and slightly under 90 inches per second at the high speed, which is what we want. So I think this is all working, but when I now try to initialize a tape, what happens is it goes through the process. So the initialization is the HP will try to write down some underlying track information onto the tape. So it rewinds a tape when you start the process, writes information to the entire length of the tape, and when it gets close to the end of the tape, it runs to the end to check the length of the tape, which is one of the reasons you need to modify the DC2000s. It then rewinds a tape, reads that information back, rewinds it again, and if it detects any errors in that process, it throws up an error. Expect it to be. But there's no data coming out of it, which I think is why it can't see the formatting information. So that's what I want to start looking at. I'll just put a tape in and show you what it does at the moment, and then we'll go from there. Okay, I've got the HP powered up. We'll fit a tape into the drive. This is a standard DC 100 tape. And what I will do now is try to initialize this tape. So I'm going to type in the initialize command. I'll move the camera in a minute so you can see what's on the screen. Okay, so I've typed in the initialization command. We'll now try to run this and see what happens. So it started the process, it rewound the tape, and now it's winding the tape forward, and in theory it should be writing down the track information. We could put a scope on this, but we'll come back to that later. And it will do this for the entire length of the tape. And when it gets close to the end of the tape, it will fast forward until it finds the end of tape holes. It will then rewind the tape and it will try to read that information back. We're getting close to the end of the tape now, so it should shortly start to fast forward. There it goes, and now it's rewinding the tape to the beginning, and it should then try to read the tape, and it's going to try and read back the formatting information that it's just written down. So now it's reading the tape back. Nothing showing on the CRT display, just sits there with a blinking cursor while it's doing this. And it's now reading back, but if it detected any errors while it's doing this, it should come up with an error. And again, it takes a while to read to the end of the tape, so we'll just wait until it gets to the end. it's now going to rewind the tape. So if for any reason it couldn't read back the correct information, it should come up with an error. But that is of course assuming it can read anything at all. I think the firmware is getting a bit confused. Okay, so this time we are getting an error 85. Move the camera. So I don't know if you can see that on the screen, but we're getting an error 85 showing. Does exactly the same thing with the DC2000 tapes if I fit the modification resistor, and I've tried this with a number of tapes and it does exactly the same thing with all of them. So the next thing I need to do is start looking at the tacho board. There's clearly a fault with this. Now I did find some faults with both tacho boards, but I've only dealt with this first one so far, and the issue was similar to what I found with the CPU cards, in that the hybrid module was not making good contact with the board. Flip this over, and we've got this hybrid module, and this is connected to the board in a almost identical way to the main CPUs in this machine, in as much as you have this heatsink and then you have these gold zebra strips around the outside, and the heatsink compresses the hybrid module, sandwiches the zebra strips, and it should make contact down to some gold contacts on the board. But when I put this on, I noticed there wasn't any compression of the zebra strips. I've only ever seen that a couple of times previously, but it is a number of years since I worked on one of these, so I'm starting to think that maybe the age is coming into effect now for these zebra strips, and they are now getting just too compressed with age. So I did exactly the same thing as I did with the previous one. I took off about 0.05 millimeters, just a piece of plate glass, some emery paper, just worked it around, made sure I got a nice even amount taken off, bolted it back on, and these boards are quite easy to test because the gold is exposed on the hybrid module. As long as you're very careful with your test probes, you can check that each one is connected to the appropriate connection on the board. On this board I found, I think, 3 or 4 that weren't making good contact. This one has about 7. In fact, if I plug this board in, it stops this tacho working as well, so I think there are some other faults on this board. So we'll probably come back and do a separate video to repair this one. But in this video I want to start trying to figure out why we're not seeing the correct data from the tape, which is what I'm assuming is the problem. I did put a scope on when I was doing the initial testing, and I was seeing write current and data output from the read-write head when it was trying to write and read the tape. So I don't think it's the tape drive, I don't think it's the tape head, and I don't think it's the amplifier on the tape drive itself. But we'll check, we'll see if we're getting anything going into the tacho board. So next thing we need to do is get the schematic for the tacho board and see what we need to be looking at. Okay, so I've grabbed the schematic. Incidentally, when you're working on these, it's a good idea when you're not actively doing something to switch them off if you have the top cover removed. The reason is that with the cover removed there isn't any air flowing past the two hybrid CPUs, and they do get very hot if you leave them running for too long. So it's a good idea to switch off the machine every so often to let them cool down. I don't think they'd overheat and destroy themselves, but as I say, they do get very hot and it's not really worth taking the risk. And also the zebra strips themselves really don't like getting too hot, so it's a good idea to turn the machine off if you're not actively doing something with it. So now looking at the schematic, what we have is the data. This bottom section is just the motor drive, and I'm fairly sure that's working, so we'll ignore that for now. We'll come back to it later if we're getting a problem. I don't know how clearly you'll be able to see this, but the parts we're looking at is we have this first op amp. This is really a filter and amplifier, so the data comes in here from the tape drive. And looking at the block diagram, this is actually the other way around, but we have this low pass amplifier, that's where the data comes in. We then go through, as I said, the system is trying to measure pulse widths. So what it does is it uses a differentiator circuit to turn what is effectively a square wave, or series of square wave signals coming into it, into a series of spikes. So if it's a positive going edge to the square wave, you get a positive spike, and if it's a negative going edge, you get a negative spike. And it does that so it can use a peak detector to very accurately measure the position of the edge. And so what it's bear in mind, it will be there'll be noise on this because it's obviously an imperfect system when you're reading from tapes. And what it's looking for is the spacing of those edges. But then, because the edges are alternating between positive and negative, it has to account for that by having a threshold adjustment system so it can properly identify the point at which if you like, the peak of those spikes occurs, and it can then use that as a very accurate way to time the signal of the data coming from the tape. So what we're going to do now is start looking at the data coming in, and one of the complications with this type of system is it's fairly dynamic, in as much as the tacho controller, this large device, is going to select the mode of operation based on what it currently thinks is going on. And on a system that's working, it's fine, but on a system like this that's not working, all bets are off. It could do anything. So what we're going to do is start in part of the system that does not require us to rely on the tacho to give out any specific signals. So we know the data is going to come through here irrespective of what the tacho is doing, as long as it's trying to read or write. And the data will come down here, and it will then start generating signals based on the data coming from the tape. We should then end up with two signals. One is a flux transition signal, basically the signal generated when one of these spikes occurs. And then we have another signal that is to tell the tacho whether the signal is effectively high or low, so it can keep track of where it is in that kind of square wave sequence. So we want to look to see if we're getting these two signals, and if we're not, we'll work our way back and see where the signal disappears. Now, the one that has least ambiguity is this one, so we'll check to see if we're getting data coming out of this, especially a couple of comparators. And if we're not getting data coming out of here, we can check the op amp, and if we are getting data there, we can look at the thresholds to see if the threshold generation system is working. One of the threshold generation signals or levels comes from the tape drive itself. There's a fixed resistor on the tape drive that's selected during manufacture of the tape drive, and that's used to compensate for the particular drive. So if you swap from one drive to another, or one tacho board to another, you don't have to readjust everything on the tape drive. But it's a fixed resistor, and it works the same as this resistor here. You probably can't see it, but there's a fixed resistor that's used to control the threshold, and then there's another one, but it's on the tape drive. So we'll start by looking at this, and I'm going to go and get a blow up of this part of the circuit. I can't actually read this, it's the quality of the print's too low, so I'll go and get this blown up, and then we'll see if we can start doing some fault finding on the tacho board. Okay, I've blown up that part of the circuit, and what we're looking at is these 2 points. That's U12 pins 10 and 12, and we should be getting quite a good signal here as long as the tape is being read. So what I'm going to do is put the test ROM into the machine, and we can use the tape test procedures in the test ROM. I can't run the test tape, of course, but there is luckily a tape test procedure in the test ROM. and we'll use that to just try to generate some data coming out of the tape, and we'll see if we're getting anything at these 2 points. So we'll plug in the test ROM, power up the machine, getting 2 beeps, so that's working. Just waiting for the screen to come to life so I can see what I'm typing in. And while we're doing that, we'll look for U12. So that is this device here. And as I said, we're looking for pins 10 and 12. And then we want the tape test routine. Okay, and we'll see if this is going to work. Okay, so that should still be running. So it's doing something similar to the machine. It's starting the test and then stopping. So pin 10, and we'll see if we're getting anything on this pin. Try pin 12. Okay, so we're getting data on pin 12, which is here. So let's see if we're getting any above threshold data going into this latch. So that's pin 1 of U17. So U17 is this one. So we should be seeing some data going into that pin. Okay, try that again, make sure I'm on the pin. I'm working on the camera here, so I can't really see that clearly what I'm doing, but we should be getting a signal at that point. Nothing. Let's go back to U12 and see if the signal's still there. Which it is. So I'll go back to the schematic. So we're getting a signal here, but nothing up here. Okay, so let's look at Q. We've got 2 transistors here. These are someone made a comment on a video some time ago now, saying that you could swap FETs with transistors because they're identical, and I pointed out that you can't do that. They are very different. Not only that, but you can't always swap one bipolar transistor for another type of bipolar transistor. In fact, you very rarely can just randomly interchange them. So we've got these 2 transistors. This first one is actually fairly important. This is going to set the speed of operation of this. This is really a buffer, and this first transistor is going to set the speed of operation, and it needs to be a very fast transistor. So I should check this Q5 first. Okay, the transistors aren't marked. I just need to go and find out which one's which. Okay, so the 2 we're looking at is this one's Q5, this one's Q4. So we should be getting a signal going into Q5, which is there. So we'll try that. And we are. It's lower amplitude, of course, because it's going into the base of a transistor. And then the output of that should be going to the second transistor, so we'll try that. Okay, just make sure I'm on the pin. Try that again. Okay, there's nothing there. Let's just go back to the base of Q5, make sure that's still giving us something. So I can't actually see the connection from where I am. Okay, so we'll try that again. Okay, well, so we might have found our culprit already, at least one of them. So we're getting a signal on the base of this transistor, but nothing on the collector. It should just be a simple inversion of the data going in. And there's nothing coming out of here at all, of course, because there's nothing coming out of Q5. So I'll just turn off the HP. So what I'm going to do now is get a multimeter and just buzz this out and see if I can detect anything obviously wrong with it. It might be a short from base to ground, and we'll see if we can figure out if this is working while it's in circuit. If not, I'll pop it out of the board and we'll test it out of the board. Okay, well, I've used a multimeter and it does appear that Q5 is indeed faulty. I've even compared it with the Q5 on this board and I'm getting different readings. So either this one is faulty and this one's fine, or there's a fault with Q5 itself or one of the components around it. It could be one of the capacitors that are used to control the speed of operation. This is really kind of positive feedback, and it might be that there's a problem with this, but I somehow doubt it. We'd still get something showing if that was the case. It's not this one because we're getting data right up to the base, so most likely it's the transistor itself. Could be the second transistor, of course, but I'm going to start by removing Q5 from the board and we'll see if it's faulty. I've removed the transistor from the board, and what we'll do now is put this into the transistor tester and see if it is actually showing us faulty. Power this up and see what it says. Okay, well, that's not right. Make sure it's in there properly and try repeating the test. It's coming back with the same. We'll try spinning it around. Then it's the diode between pins 2 and 3, which is obviously incorrect. So I've now rotated it 180 degrees and we'll see what it comes up with this time. And it's saying diode between pins 1 and 2, so it's not a connection on here. It looks like we have an open circuit between 2 of the pins. So this transistor is indeed faulty. I'll test the other one and see if that's faulty as well. In the meantime, I need to find a replacement for this. Fairly unusual device. It's a high frequency. What I'll probably do just for the initial testing is put some turn pin sockets into the board in the same way I did with a tape drive, so I can test different transistor types. I'm not going to hold out much hope of finding one of these. I don't want to steal the one out of the other taco board because I would like to get that board working as well. So I'll try and find an alternative that actually works, and then I can repeat this testing and see if we can get any further. Okay, I've just dropped in a BC547 for now. It's certainly won't be good enough for this, but we should still be able to see some data coming out. So what we'll do now is look at the output of this circuit. So we'll look at pin 1 of U17. We were getting nothing here before. Even if the transistor's not suitable for this, we should still see something there, so we'll check that. We've got the same test running that we had previously. I'll run the test. And hopefully, as you can see on the scope, we are now getting something. So what I'll do is I'll experiment with different transistors, try and find one that's suitable. If I need to, I can pop the transistor out of the other board just to test it in the curve tracer and try and get some idea as to what the characteristics are. Can't really find a type for this. There is a number on it, and I can't find this in the HP equivalents anywhere. This may of course be a replacement. I don't think it is, but I'll try and find a spec for this and a suitable replacement. But in the meantime, we've made a bit of progress. We are now at least getting some signal through that part of the circuit. We were getting nothing before, and hopefully in the next video we'll get this card up and running.